All right, here we're looking at 5.2, and our goal in 5.2 is two-part. All right, the first part is to multiply a scalar with a matrix. So we're going to need to find out what a scalar is. And then, meaning so there's two parts. We're going to add and subtract matrices of appropriate dimensions. All right. So before we get started, let's go dive in. What is a scalar? All right, so a scalar. This is a non-zero number that multiplies with each entry of a matrix. And I really, for this word, I should have written the word element. All right, so the scalar is a non-zero number that's going to multiply with each element inside the matrix. Okay? So let's take a look at an example of what that might be. So an example, let's do 4, and then let's multiply that with 0, -1, 7, 2, 3, -5. All right, so here we have a scalar. The scalar in this instance is the number 4. So here is the scalar, right? It is going to scale the matrix. In other words, it's going to make it bigger or smaller. All right, and this is the size of this matrix. It has 2 rows, 1, 2, 3 columns. So this is a 2 by 3. All right. So the result is going to end up being a 2 by 3 matrix as well. So the scalar, the 4, is going to multiply with each entry within the matrix. So I'm going to go ahead and multiply the 4 by all 6 of these numbers. So 4 times 0 is 0. 4 times -1 is -4. 4 times 7 is 28. 4 times 2 is a regular 8. 4 times 3 is 12. And 4 times -5 is -20. All right, so all I've done is multiplied the scalar with the matrix, and we end up with a new matrix of the exact same size. The properties of the matrix haven't changed, but the elements within the matrix have. Now let's see that the size of the dimensions didn't change, but the matrix elements did change. Okay, and again, a scalar cannot be 0. 0 times a matrix is really, really, really silly, and nobody's ever done it. So it's not something you'll ever see. So that's multiplying a scalar. Now, let's get to our second goal. Our second goal is to add and subtract matrices of appropriate dimensions. So note, in order to add or subtract any two matrices, they must have the exact same dimensions. All right, so, ran off the board there. All right, so in order to add or subtract any two matrices, they must have the exact same dimensions. All right, if they don't have the same dimensions, then we would say that it is undefined. You cannot add and subtract these because they're not the same. Okay, so let's take a look at an example. I'm going to do an example of subtraction because I want you to see how that looks. Let's take a look. We have -5, 2, -2, 4, -2, 0. And we're going to subtract 6, -5, -6, 1, 3, and -3. All right. So let's take a look. The size of the first matrix, the dimensions here is 2 rows, 3 columns. So this is a 2 by 3. Here I have 2 rows, 3 columns, and that's a 2 by 3. All right. Now, what we're going to do is we're going to subtract. We're going to add. So whenever we do this, right? So I'm going to write this down below. All right, we simply add or subtract corresponding elements. That's it. Okay? So, I'm going to take a middle step here. And the reason why I'm going to do that is because of all of these negatives, and we're subtracting. So if you try and do this in your head, it can get a little confusing. So I'm going to do a middle step here before I get to my final answer. So what I'm going to do is I'm going to quite literally take each one of these numbers and rewrite them over here. Each one of these operations. Right? So my first one is negative 5 minus 6. So I'm going to write negative 5 minus 6. 2 minus negative 5. 2 minus negative 5. And notice how when my second number is negative, I put it in parentheses. All right? That is to make sure that I know to change the signs here. All right? Negative 2 minus negative 6. So I have negative 2 minus negative 6. 4 minus 1. Negative 2 minus 3. And 0 minus negative 3. 0 minus negative 3. And notice we had negative 5, negative 6, negative 3. These are all in parentheses over here. Okay? There's a reason behind that. Whenever you subtract a negative, it's the same as adding a positive. Well, now I could go through and clean this up. Negative 5 minus 6 is negative 11. 2 minus a negative 5 is the same thing as saying 2 plus 5, and that would give us 7. Negative 2 minus a negative 6 is the same thing as negative 2 plus a positive 6, so that would give us 4. 4 minus 1 is 3. Negative 2 minus 3 is negative 5. And 0 minus a negative 3 is the same thing as saying 0 plus 3 to get 3. And notice how this middle step is really intended to make sure everything's nice and clean and done in the right order. I'm going to do one more off the homework that's might seem a little bit more complicated. It may seem a little more complicated, but it's really not. Follow along here as we do this. Now this one's right out of the homework. We have z minus 5, negative 6, negative 1 minus 6z, 3y. This plus negative 3y, 3z, 5 plus z, and 4z. All right, so here we have expressions, right? So this is z minus 5. It's not a 7, it's a z. So here we have expressions. So let's think about the size of these guys. I have 1, 2, 3, 4 rows. There's 4 rows, but it may look like there's like 2 columns with some missing entries. It's not true. There's really only 1 column here. And this again is a 4 by 1. So I'm going to take each entry, and without trying to get fancy with it, I'm just going to write each entry as we go. So z minus 5 plus a negative 3y. So z minus 5 plus negative 3y. And then I have negative 6 plus 3z, negative 1 minus 6z, plus 5 plus z, and then 3y plus 4z. And now I'm going to ask myself, do I have any like terms? So, can I combine any of my like terms on the first entry? No, there's nothing else that's just a z or a number or a y. So here, my final answer, we're going to get z minus 5 minus 3y. Plus a negative is the same thing as saying minus. Negative 6 plus 3z, I cannot combine any like terms there. Negative 1 minus 6z plus 5 plus z, there's several like terms. Negative 1 plus 5 is a 4. Negative 6z plus z is a negative 5z. And then 3y plus 4z, there's nothing I can do with that. And we're done. Now that should be enough to get you through your homework. If you have any questions, as always, make sure you ask.